is visible to all of this. Able to hear my voice? Shall we start the session? Masasi Kumar sir. Sai Kumar sir.
Yes, we can start the session.
Shall we start? Okay. Happy afternoon to everyone present here. On behalf of the Department of MCA, SRM Institute of Science and Technology, I welcome you all to this 2 weeks International Virtual PDP on Data Science, the revelation of the modern digital era. Today, we are in day 11 of 2 weeks virtual PDP session on data science, banking, non-banking financial companies ecosystem. I deem it honor and privilege in introducing our chief guest of the day, Mr. Sai Kumar, Divisional Manager, Analytics, TVS Credit, Hyderabad. Mr. Sai Kumar is an analytics leader with around 12 years of experience in implementing analytical solutions. He is a BTech and MBA professional from International Institute of Information Technology. In his previous role, With one of the early NBFC in the country, he has worked as a head analytics, helping the business set up the analytics function from the grouping up and scaling it up eventually to a bigger team. He has worked with diversified teams across the organization in implementing a conversational bot, a multi-layered architecture in the ecosystem through designing use cases, ramping up the data landscape, and building microservices layer with the help of business, technology, and strategic partner teams. Prior to this, he was with banking chains like HSBC and Citibanking. We're extremely happy to have such an eminent personality among us today. Thank you, sir, for accepting our invitation and being with us today. I invite you to take over the session, sir.
Thank you, Uma, for the brief. And
Yes.
I'm glad to be part of this session. Welcome all. So today, I will walk you guys. We'll talk about how the data science has been in practice in banking industry, especially in the NBFC space. Okay. So for that, let me start with so is my screen visible, Uma?
Yes, sir, it's visible.
Yes. Thank you. So let's talk about how data science is being applied in the banking and NBFC ecosystem, especially NBFC system. NBFCs, again, we'll talk about what NBFCs and everything, how it's being implemented. The topics that we'll cover today will be the NBFCs and their role in the country's growth, and we'll quickly move to how data science is being applied across industries, and eventually move to how data science is being applied in the NBFC space. And we'll talk about mainly a business use case that one of the business use cases that we work in our company. Okay, we'll talk about the objectives, challenges, approach, the deployment architecture that we have designed and deployed, and the results from that. Hope this will be an enjoyable session. Please park your question for the end of the discussion. Uh, uh, Moving on, NBFCs, as the name suggests, it's non-banking financial companies. Okay, why are NBFCs? I mean, more adapting to data science ecosystem than the traditional banks. First of all, let me talk about what NBFCs are, and how they are different from banks, and how banks and NBFC the ecosystem is in data science and applications over the time. NBFC, as is written, so it's a non-banking financial company. What it comes under, the license license will be given by RBI, and for some of the NBFCs, who are already under the regulatory bodies like SEBI and IRDA, they don't need a license from RBI to start the operation. But however, for a company, for an NBFC to be set up, one is the license certification that we need to get from the government regulatory bodies. The second is the net flow cash, the liquid cash flow, the net funds that the owner has should be a minimum of 2 crore for a person or the group of people to start an NBFC. That's the criteria for anybody to start an NBFC. And what it does is what we talk about. So it does everything, almost all everything. Let me rephrase that. When I say almost all, yes, they do lending. They lend to every customer. They can lend to every customer in the market, every middle class, minor class, upper class, everybody. And what differs NBFC from the banks is that they cannot accept demand deposits. We have two types of deposits, like term deposits and demand deposits. While they can accept deposits, but they cannot accept demand deposits. Meaning, you can't open a saving account with NBFCs like you do for the regular scheduled and commercial banks. You can have your savings account, right? You can withdraw whenever you want. You can put your money. Of course, you'll have a little interest rate that you gain, but you cannot, you do not have that option with NBFCs. And moreover, NBFCs are more risk takers than banks. Why? Banks, for a customer to apply for a loan in banks, you need to have lots and lots of documentation. Like, you need to file, you need to produce your ITRs, you need to produce your pay slips, last thing is pay slips, you need to produce a lot of KYC documents, which a general salaried employee will have. And that's the reason why general salaried employees will go to banks for loans, because they have all these KYC documents and then they are given a relatively lesser rate of interest compared to the NBFCs. On the other hand, the unorganized sector, like we have the pharmacies, bakery shops, the pawn shops, we have small business popping up, popping around nearby places. They have their business or their, daily bread and purpose. They do not have any documents apart from the credit receipts or the, the credit card swipes, transactions that they have. They do not have any other uh, 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 stringent or robust documents like a regular solid person will have. That kind of a customer, we have lots and lots of such customers in the country, and there is a lot of unmet credit demand for such customers in the country. This is way back 2010 and 2008 when NBFCs were only a handful. Now, as we speak today, we have hundreds and hundreds of NBFCs in the country who are catering to that unorganized sector who cannot afford to avail a loan in the regular scheduled banks because of the unavailability of the documents. Now, what is it that NBFCs are doing that banks couldn't do? Why are NBFCs are able to cater to the unorganized sector, and why the age-old banks are not catering? Catering in the sense they are catering, but not up to the mark, up to what they should be. Had they been catering to the other unorganized sectors, there wouldn't be any provision for NBFCs to come up, and the government wouldn't have given license to all these NBFCs. Correct? So there are two things why banks will not offer. Like I said, one is the lack of documentation, lack of enough credibility for the customer. Second thing, since they don't have any existing loan, they're all they're not educated, or they're not somehow credit worthy. Meaning they don't have any credit exposure in the past. They're not taking any loan, personal loan, anything. All they used to do is they go to nearby landowner or pawn broker. They actually take monies for certain higher interest, and then they repay. That was the system back then, 15, 20 years ago. But then with this NBFC is popping up, so they are ready to take that risk and give that loan to the unorganized sector with so and so conditions. They have their own methodology of underwriting the customers, which we call credit underwriting. We're not getting into those details now. Credit underwriting is a huge journey in NBFC space or even in the banking space. We'll come to that if time permits. Now that's the main difference between NBFCs and banks. Moving on, we'll slowly move to the data science now. Okay, our core area of discussion today, um, and then we'll slowly slip on to data science across industries, and then eventually data science how is being used in NBFCs, and we'll talk about one of the use cases. So, what is data science? As you all know, it's science of data. Simply put, it's science of data. Okay, good. It's science of data, but why is it so complicated? Why are people going halla about it? Why are people going hoopla about it? It's for this reason. When you say science of data, obviously there's a process built in it. Okay, it's not like you fly the numbers around in an Excel sheet and then you get something fancy and then you say wow, that's done. No, it's not that. There's a process. When you say science, it's a process. You have a process to it. You have a data. You need to identify the data sources first. You need to understand whether the data source that you collecting are having enough information or enough readable information. The reason why I say readable information, because that's a big challenge that we face as communities today. We don't have enough readable data in the unorganized sector. We have huge data for the organized sector, like for employees, but we don't have enough data. We don't have alternate data, right? unorganized sector. It's slowly popping up for the past 2 3 years with advent of small unicorns or startups coming up with new ideas with pulling up the data from different sources and using different technologies to pull up the data. But then we're not there yet. Yes, we have bettered in the past 2 3 months in collecting the data and making the data readable, making the data structured over the time, but we are not there. Okay, so that's one thing. Now, once we identify the data, once we have the data structure, and once we have the data in a readable format, so what do? You mine it, meaning you extract for patterns in the data, right? You extract it's data. It's all structured data from it's all columns. I mean, we're talking about audio and video data, lots and lots of data, text-based data. So I mean, they're all unstructured data. They are based to read that stuff. I mean, unstructured data as well. We have tools and techniques to read that unstructured data. But all in all, when you say data mining, it's about extracting the data patterns from structured and unstructured data. Now, once you have that EDA done. What do? You do predictive analytics. You deploy, you build models, you try and understand, you feed the data into the model, you let the model, read insights or get insights from the data, and then you show the results. And you also have model built to a different, sample altogether, and then you try whether the model is valid and validating itself or not. Things like that. This is the process. So once you validate the data and once your leaking is done, so now that you say that, hey, I have the data, I verified it, I've cleaned the data, I've mined the data, I've done all the ranking that I need to do with the data, and I've deployed my predictive analytics techniques, to build a model, to feed the model with the data enough data. Now, once the model is built, I tested the model on a different environment because train and test have to be different of this data. So, I mean, you fed the data with a training sample and it has to work in all environments. That's why you do training and test. Okay. Again, there are out of time in sample. There are a lot of other things. We're not going to get there. We're not going that deeper now. So you validate it and then you deploy it. Why is this is about science of data, and why is data science so important, and why is it become so important for the past, let's say, 7 8 years, I mean, especially. Okay. In the corporate world, it's become very important in the past 7 8 years. In the past 3 4 years, it's gaining momentum. The reason I say that is because for every I read the stats about in an article. I read the stats about the availability of data science experts in the market today to the demand that we have. Can you believe it is 3 versus 20? We have a 20 data scientists requirement in the market, and we have only 3 people who can fulfill that role. I repeat, we have only 3 people with all the fundamentals, basics and fundamentals, and we can fit in the role that is required by the corporate clients. That is the demand that we have. Why the demand? Again, gone are the days where we used to, generate, where the businesses used to generate revenue only from the sales. Okay, I'm a manufacturing company. I have new cars. I sell them, and then I make my profit. I make my margin. Okay. Now, how do I make more revenue from the same customer? How do I make him, how do I cross sell or upsell to the same customer? How do I generate more revenue? Cross sell or upsell is nothing but generating more revenue from the same customer, isn't it? So, how do I upsell a product? How do I cross sell a product to the customer so that I can generate more revenue? Okay, because with the competition around, we have, let's say, 100 cars as a requirement, and we have 20 or 25 manufacturers in the market. So you can cater to hardly you can take a pie in it. Hardly will be a 20% or 30% market shareholder. It's very difficult in this scenario to acquire customers. Okay. Now that's the reason why acquisition is more important and retention is more important, because we do not want to lose the customer once he's our customer. We did not want him to go to look out for any other opportunities in my domain for any of his requirements. Meaning, if I sell a Maruti car, I think I talk to a customer, he has to come back to me for any of the components, for any of the services, everything. That's why we have service showrooms, right? So, I mean, if you think back 10 years ago, there was only Maruti Suzuki service showrooms across each and every nook and corner. But we have now, as we speak today, we have every manufacturer having its presence, physical presence in nearby locality. Why? Because they don't want to lose the customer. They want to generate more revenue by upselling to the customer, by doing the survey, by doing the periodic maintenance to the car, by selling spare parts to the car to the customer. This is where importance has come. So now we can generate revenue. This is one of the use cases or one of the reasons why the data has become more important. So it has to be said when there is a business requirement, when there is a business problem, when there is a business pain point, only then you come up with different technologies, different tools, right? Different applications altogether. So with this one, uh, so how are we using data science to do upsell and cross sell? That is the thing. So you apply models, you target the customer, you understand his customer profile, 360 degrees profile, and do some churning, and then come up with, say, was out of these 100 customers, I can actually reach out to these 20 customers, top 20 creamy customers, and I can just do an upsell or a cross sell to them. That way, I get a revenue from a minimal cost incursion. I don't have to spend to each and every 100 of the customers that I've rolled out my task to. If I know who will be interested to come back to me for doing an upsell or cross sell, only then only for those customers, it is enough if I spend only for those customers, isn't it? Because it's all money eventually. Marketing and everything is an expense driven, right? It's huge expense driven. Okay. So it's all money driven. So you need to know the optimal customers who you can target to get them back to your business. That's where these data science applies. So you need to understand the data. You need to read the data. You need to study the data. You need to research the data. That is where the science of data comes. That's what data science is about. Moving ahead, where all we are applying data science. Okay, we have every three companies out of four deploy data science in large or small scale. Of course, maybe they don't have capacity to retain the workforce or hire a workforce and then have them captive. But at least they are working they're outsourcing their work to analytic consultant to get the job done. So there is no industry, to my knowledge today. At least 75% of the industries that we see, that we hear, that we talk to, have analytics built in their DNA one or the other way. Examples: e-commerce. What is what does e-commerce have to do with analytics? Yes, there is. One such example is competitive pricing. You have Amazon, you have Flipkart, you have Myntra, you have everybody, you have Big Basket, everybody. So how do they decide what should be? See, I have a product, I have a jean shirt, I have a trouser to buy, and the same product is available in Flipkart, Amazon, and Myntra. Now, who should I reach out to make a purchase? As a customer, I have these three digital avenues. I can go to Amazon, I can go to Flipkart, I can go to Myntra. Why will I go to one of these three and choose a product from there? Because it's competitive pricing. Because it's the customer experience is good. Because maybe the terms and conditions, the refund terms and conditions are good. Every customer has their own requirements, right? So you have to have a better customer experience for the customer to keep coming to you, and there has to be competitive pricing, especially in e-commerce market. Okay? For a product, the same product, Amazon might quote 500, Flipkart might quote 550, and Myntra might quote 570. Who will I go to eventually? First of all, I'll go to Amazon because it's competitive pricing. And I know Amazon is a trustworthy partner, and no matter what, even if after the delivery, if the piece is damaged, always I have a delivery guy who will come and pick it up. So I have that trustworthiness with the brand. There are many other use cases in the e-commerce industry. Okay, not just one. Okay. How do they decide the pricing is one thing that I just said. What are the products that customers are interested in? Is some sentiment analysis that they carry out to show the respective products to the customer. It is what we call customization, product customization. Today, I log into Amazon Flipkart site. I see the products, I browse. I'm just window shopping today. Okay, I'm not in the mood to purchase anything, but I just want to see. I have in mind that I want to purchase treasure. Maybe 2 days down the line, and 3 days down the line. I just go to Amazon and surf surf their website, and I just come back. I just have an idea. I'll get an information on how the product is looking like and what are the price ranges. Now, Amazon knows that I've looked for a product in this site, in their site. What do? They reach out to me. The moment I log out of the site, they reach out to me either by WhatsApp or SMS or any other channels. Or maybe even after 1 hour, I go back to the same site, I'll have a customized recommendation. You have searched for these things. You're interested in, these are the items that you would like to explore. There'll be a bottom bar that comes up, right? So this is all customized recommendation. This is all AI and ML. Moving to automotive industry, again, sales volume prediction, like we just spoke earlier. Healthcare, again, medical diagnosis. Okay, medical diagnosis, how? I mean, all the radiologists and all the diagnosis that is being done, diagnostic labs that we have to do, are all again ML and AI, because you have certain tests that follow certain mathematical calculations to the back end. You decide the rates have to be so and so, and if you're in the rates, you're not diagnosed. If you're above those limits, then you're positive. If you're not within that limits, you're negative. Right? Again, logistics. There's a big use case here, which is called telematics. I'm talking about the truck logistics or freight logistics, where we have truck carriers who carry goods from one state to other place, one location to other location. So they use telematics. Telematics is nothing but you install a device in the truck and you understand what is the availability of that vehicle and when will that vehicle be available. So I'm a truck carrier. I have 50 trucks and I have an order tomorrow and I don't know which truck I can allocate to that customer, that order. That is where telematics comes in. Telematics tells it pulls up all the data from the truck, it navigates data, it takes the navigation data and pulls up all the information from the respective trucks and say, was this truck will be available, this is about to reach the destination and maybe 3 years from now, and this will be available for the next order. That's an optimization, right? Logistics optimization, fleet optimization. Moving to insurance, again, insurance, uh, it's about fraud detection. Fraud detection we do in banking environment also. Premium payments prediction, whether a customer will pay a premium or not, is something that the insurance companies do, because insurance company business model is mainly on the premiums, isn't it? I mean, today, as a credit card customer, as a home loan customer, if you don't pay now, you have to pay the interest and then pay it later. You're a default customer. In the financial environment, if I am a credit customer and I don't pay my dues, even the minimum dues within the cycle, I'm a DPD customer. If my DPD is 0, then I'm a safe customer. If my DPD is greater than 1, DPD is nothing but days past due. So you pass these many days after your due date. If DPD is greater than 0, then you're a default customer. Default customer. Sorry, delinquent customer. You're a delinquent customer. If you don't pay even after continual reminders and after 3 cycles, then you're a default customer. Every company has their own logics and rules built behind it. If it is 90 plus DPD, then you're default. If it's 60 plus DPD, you get default. If you're 80 plus 180 plus DPD, you're default based on the product and the company policy that is being decided. But in the insurance industry, we don't have such. If you're not paying premium, there's no alert, there's no civil score that goes and says, "Well, this guy is not paying a paid premium, so he's not a credit worthy customer." There's no such thing done. This is the kind of data that we're talking about. This is the kind of alternate data that we're talking about. Wherein this is a payment discipline, right? If you're not paying your premium, so you signed up for an insurance, and you're not paying your premium on time, yearly or monthly, whatever it is, whatever you've chosen to when you took the insurance initially. If you're not paying your premium on time, then you're not a financially disciplined customer. The reason why we are not using this as a critical indicator to decide whether you're credit worthy or not, because monthly premium is what hardly. I mean, even if you go for a high policy for the senior adults, it's hardly 25,000. So monthly it will be 2,000. So if you're not paying 2,000, then you'll not be termed as a non-credit-worthy customer, because we're talking about lakhs here. We're talking about loans, personal loans, home loans, which will be in crores, and the EMIs will be in lakhs or thousands, 50, 60, 70,000. So this is not being as an indicator currently at the moment, some of the companies, but mind you, there are companies like NBFCs and some of the NBFCs, they are using this as an indicator to decide the financial stamina or not stamina, sorry, financial discipline of the customer. Now, finally, banking. Let's talk about how, I hope my screen is completely visible. Just a second. Now, coming to how, what are the business use cases for NBFC or banking industries? Again, we spoke about fraud detection, which we call, it comes under risk umbrella. We have different departments in the NBFC or banking environments. Just to give you a perspective, we'll have sales, we'll have credit, we'll have collections. These are the main three pillars. Every other departments like IT, analytics, these are all support functions. Risk is a part of credit. Okay, so we call it credit risk. Why you use it, how you use it, maybe we'll talk about later. Risk is about identifying the fraud before it happens. Again, and there is credit underwriting. I think I just gave a flavor of how credit underwriting is being done. Credit underwriting is nothing but assessing a customer during his onboard stage. When I say onboard, before him or her becoming a customer, whether it is a good or bad customer. How do you do that? And there are ways to do that. We'll talk about it in time for this, especially about this credit underwriting. Now, coming to marketing and customer service. See, like I said, every business, every industry, every business function within an industry uses data science. The problems are different, the results are different, approach is different. But eventually, it's the same technique, same tools. Okay. You apply a loss integration for one. Let's say I have two business problems, one from the marketing, one from the credit domain. Okay. Eventually, I mean, there are two business problems for me. But if I'm applying logistic regression or maybe neural networks to both the problems, then they are different models. Algorithms are same, models are different. Why? Algorithms fed on different data. Algorithms plus data is equal to model. That's why we have different models. Now, I came across this one question, the same question that I'm asking for now, is that why is that we are calling different models? I mean, as long as we are using maybe neural networks, or as long as we're using same algorithm and for different problems, it should be same algorithm. Why are we saying this is a different model, that is a different model? It is for this exact reason why we call them the two different models, because algorithms are the same. Science behind these algorithms is same, but you're feeding them on different data. Okay, the results that these algorithms will give on different data will be different. Maybe for one business problem, the neural network ANN will work, but for the other neural problem, the ANN might not work. Maybe random forest or executes will work, isn't it? So that's it. So moving to marketing and customer service. So we have again models, propensity models, customer engagement models, mainly for customer service and customer engagement. The industry today, be it any industry, is inclined to using bots because that will save lots and lots of costs. I'll give you an example. We operate at a cost of 25 rupees for a manned resource to attend a call for a call center. Okay, we are a business type. So all our customers will have queries. We lend loans, so we lend to customers and they'll have queries. They'll call the call center, and there has to be somebody who handles that phone customer from the contact center, and he'll take maybe 30 seconds or 3 minutes based on the requirement and based on the satisfaction of the customer to close the call. So we on an average spend around 25 rupees per customer to attend and answer that call. Now we have 40,000 such calls, 40,000 such customers making calls on a monthly basis. Minimum 40,000 customers making calls on a monthly basis. That's for one product company. So just 2 units. Okay. Now if I have to answer all those calls, it's going to cost me what? 1 crore? Or is it 10 lakhs? 10 lakhs, right? Yes, 10 lakhs. Now, what if all those queries were answered by an automatic bot or automated system? You cannot call it bot at this case, automated system. We have IVRs, still the queries are not being, the 40 or 60% of the queries are again routed to the manned calls. How do I eradicate or how do you eliminate that process? How do you make that process straight through? Is using the bots. HDFC, I'm not sure how many of you have seen the HDFC UA bot as we speak today in the market, has designed 7,000 use cases. I'm sorry, I'm quoting the names also because it's for good. It's a positive sign on it. Have designed 7,000 use cases for bot answering. It took them 2 years. It took them many man efforts, but eventually they were successful. That's the first company in India, first Indian banking ecosystem in India that has successfully deployed query or the answering the queries through bot. Okay, going back to the models, the propensity models. This is what we talk about now. Propensity models is what the use case that we are discussing, we're going to be discussing today in the marketing world. I'll tell you how it will be used. Propensity is nothing but the ability and capacity. Ability and capacity together will be called propensity in layman terms. We call them propensity models. That will tell you the ability and the capacity of a customer to repay or to do something, some activity. Moving to business use case. I'll first talk about the terminology definitions, only then you'll be able to understand the context that I'm setting up here. The business use case, and I'll explain the business use case and tell you how lead propensity is being, how propensity models are being used. Let me talk about the business use case that we had. Simple business problem statement. So again, when I say business problems will be have to be simple. Meaning, it's not that I should not have complex problems. I will always, because we are working in a dynamic environment. So no matter when, not sure what problem will come, what day. Problems will come definitely. When I say simple, we should be able to simply categorize the problem statement and make it clear. We will not be solving maybe n number of things from one model or one business statement. Statement or business problem statement has to be understood in such a way that we will be able to resolve one problem at a time. If we are resolving two other problems, that's an addition, meaning that's like an addendum to the analysis that we've done. But we're not solving for those two problems. We're solving for this particular problem. When and wherever you're able to make your problem statement very clear, then you're 20% done. Then you're 20%. Majority of the businesses or majority of the models, let me put it this way, majority of the businesses are not able to embrace the technology, the AI, the ML systems in the current scenario is because they do not know what problem they are trying to solve. The moment they understand what is the problem that they are trying to solve, the moment they're able to marry the model, marry the data to this problem, then we are there. We are there. But unfortunately, we start with one problem. Eventually, the moment we go towards the journey, we end up, digressing that problem to different directions. That's what is happening. So talking about business problem here, so how do we improve the conversion rates? I'll tell you what conversion rates are. Okay, let me talk about definitions first. So we're talking about, let me give you the pretext for the business problem here. A company X spends around, this is a real problem that we have solved. I'm not taking the names because of because of valid reasons. A company X has a marketing budget of so and so amount. They do campaigns, digital campaigns every month. Technically speaking, every day there will be some impressions going out to the digital market, digital space. Now they want to understand. So digital space is nothing but you whenever you open a Facebook, whenever you open Google pages, you'll see some ads right coming up. Those are ad sets, those are ad creatives, those are ads, digital ads. Customers who are in the Facebook and click on that ad and then come to they drive the traffic to their particular company's website. Now, ad is nothing but digital creative here. It's an infographic image. What are impressions? Impressions are the views, the number of views that are shown to the customers of the ad are impressions. Meaning, I have the same ad. I have my friend sitting beside me. He's also seeing the same ad, but on a different system. Then there are two impressions. Okay, that's what it is. It's the same ad, but two impressions. Click. Again, it's self-explanatory. You click on the page and then you go back to the page. Landing page. And once you click on the page, you land on this particular website. Ideally, in this case, it will be the website of the customer, website of the company. Lead. This probably might be a new term for the floor here, if not everybody, maybe at least for some. Lead is nothing but the user has landed in my page and has given me some basic information for me as a company, as a client to contact me. That's the lead flow. You don't call him a customer because he's not giving you enough information. He's just given you mobile number and things like that. He's a lead flow. Are there any questions? Okay. Lead, like I said, okay. So he gives basic information to the website in the website, and now the company who runs that website has a basic information on the customer, and they can reach out to him in different ways. That's a lead. Customer is when a lead converts. You have different stages of a customer life cycle, not customer life cycle, the onboarding life cycle we call it. You first create a lead, you create a login. In many cases, it's both the same. Then you have the customer supply the documents, privacy documents, and then you have a soft approval, and then you do the civil check. Then you have a prospect created, and finally the dispersal happens. Login, approval or sanction, and dispersal. Mostly these are three stages. You can dissect them, trisect them, whatever ways, but these are basically the three stages that we have in an onboarding journey of a customer in a banking environment. So these are the terminals. Now the question is, I have a customer, he's clicking on the ad and then he's coming back to my page and he has given me some information, but eventually I'm not able to make him a customer. I'm not able to convert him. Or I have 5,000 leads that have been generated. Okay, 5,000 leads, meaning I'm not talking about impressions, I'm not talking about clicks. I'm talking about the first touch point of a customer lead. Okay, first touch point of a customer with me, with my digital assets, either website, any application, any mobile app, anything. First touch point of a customer, digital touch point of a customer with me as in company. I'm not able to convert the leads into conversion. I'm not able to make him a customer. That's the problem here. So they have certain leads, they have a conversion rate of 4 to 5%, hovering around 4 to 5%. They want to improve it. Simple, as simple as that. Now the context I've given you already. Now, how did we solve this problem? Okay. We have the leads in the system, and there is a process that is being followed for a lead to eventually walk into the dealership center or walk into the branch and then provide documents and then eventually make them a customer. But somehow we are ending up with only 4% conversion rate. 4% conversion rate technically for a secured loan is good enough. Okay, but again, there's a clause. even if we are successful in making an increment of 0.5%, which is 500 basis points, we are game. Because we're talking about volumes in lakhs here. Okay. For that matter, 5,000 leads to, and if you're increasing 1%, you have got 50 more customers, and each with ticket size of lakhs, of some lakhs. Okay. That's it. Okay. Moving to how we have solved this. I will come to that. We have deployed a propensity model. We have for us to decide what is the strategy that we need to apply. Just a second.
Sir, your voice is not audible, sir.
Provisional and degree certificate attached.
Okay, am I audible now?
Sir, yes, sir, yes, sir.
So, talking about the propensity model, like I was saying, you need to understand the current status quo and the proposed status quo. Only then you'll be able to propose what is expected out of the problem, what is expected out of the solution. Now, to understand the current status quo, like I was saying, we have leads. Okay, we have a Facebook campaign that is being run by the marketing team, and it shows some billions of impressions every month. You have customers logging into the Facebook, and then they see the ad, and then they click on it. You have around if I'm not wrong, I'm talking about click through rate of 2,015,000. So I'm talking about a click-through rate of somewhere around 0.7%. Okay, and from those 0.7% clicks, meaning 15,000 roughly of 2 million. The 15,000 clicks, we are able to generate only 5,000 leads, meaning from the click stage to even creating giving us a basic information, there is a drop of 10,000 customers there. That's the first point for us to understand why they are dropping. It's not something that we need to drive from the model, because that's how the process is. Other than proposing for a process optimization, there's nothing else that we can do for those 10,000 customers. What we need to do, what we can do for this rest of the 5,000 leads or 5,000 customers, let me not call them customers, because they're not yet there. They're just leads. They're giving us the basic information. How do I get more leads to convert? The way it is current status quo is every lead is getting created, and then like I said, lead information is being passed to the contact center. Contact center team calls. They have the basic information of the customer, right? So they call the contact center. The contact center team calls the customer and then understands their interest and get an understanding whether he's interested in the product or not, and accordingly gets an appointment, and then eventually explains in the process, and then that's how the journey happens. Now, from this stage, I mean, how the leads are being assigned to the contact center. It's not like contact center guys coming up and picking up the leads, right? There's an automatic assignment of the leads from the DB, from the database to the contact center team, right? How is that assignment? There is a rule engine there. Like we have every ad engine. I mean, I'm not sure if you've heard of the ad engine. Google follows, or every search engine, every web browsing engine follows an algorithm. Okay, so here we have a rule engine where we have a priority setup. I'm talking about the current status queue of the lead, how the leads are generated and how the leads are being passed on to the contact center team. is what I'm talking about. The leads are generated. So the moment the working hours are morning 9 to 7 p.m. and then whatever the leads are generated after 7 p.m. will be stored in the DB at the back end. And the next day the contact center team comes up and then he follows this order to pick up the leads. First, he takes up the LIFO, okay, meaning FIFO, first in first out. The first lead that he sees is the one that he picks up and makes a call. Before that, he actually does some routine check. He calls the customers who made an appointment for that for a walk into the branch. All those things is routine activities. He does that, and now he picks up a lead which is generated, which is on the top. Not sorry, on the bottom. First come first serve. So he takes up the lead based on the time slot, and then he keeps calling. That's the only logic. That's only parameter. If not FIFO, somebody will have LIFO. Somebody LIFO is last in first. Somebody has some other parameters. Hardly one or two parameters. There's no algo-based logic or algo-based mechanism to decide which is the potential. I don't know. I mean, I'm picking up the lead which was created in 10 a.m. in the morning is, to me, in this approach to the system, to the logic, is no way different from a lead that was created 1 hour later, which is 11 a.m. Of course, only the time slot matters. There's a time change. Okay, that's the reason why they're giving a time priority. So they are picking up the customer who has created a lead at 10 a.m. rather than going for 11 a.m. because he has created up 10 a.m. there. So he picks up 10 a.m. there. But don't we think we thought this way? So don't you think a customer who has created a login, who has logged in later, has a higher chance than the customer who is already logged in or who has created a lead before him? There is, and vice versa. Even the 10 a.m. guy might have better better prospect or a better potential lead than the 11 a.m. guy. So this is where this logic applies, this model applies. We have created a propensity model to identify which is a potential lead, to identify the potential lead. Meaning, when I say potential lead, the lead which has the highest probability to convert, highest propensity to convert. That's what the objective is about. How did we do that? Again, we have taken the all the leads and the certain information we have. Lead is nothing but user, right? So we have enough information of the user. He gives contact number, he gives address, he gives PAN number, everything, majority of the information. I mean, when I say majority, critical information, 4 or 5 fields of the information. This is enough for me, right? Because with the PAN number, with the CIBIL check, I'll do a CIBIL pool and I'll try and understand his financial discipline across the credit bureaus. Now with the latest announcement of RBI bringing account aggregators, then I'll have more advantage, right? So with that information, I'm giving a score to the lead, and I'm actually giving deciding who is the potential lead who can actually instantly convert from it. So now the FIFO logic is out. Okay, we proposed a propensity score logic. We build scores. So any day we build scores to the leads, and then we reorder them based on the scores in the queue, and then whatever is the top in the queue will be taken up by the contact center guys. Now the question is, how do I validate my logic? How do I validate my model? Again, there are 2 dimensions to it. I can validate it from the KS and validation metrics that I have. KS, AUC, accuracy, FN score, recall, sensitivity. I can do all of this. But that is to an analytics guy. But we're talking about a business scenario where you have analytics people, you have IT people, you have marketing people, you have everybody. It's mixed. How do you explain? How do you convince the marketing team that this approach is going to work? That is where a concept called DOE comes in. This is generally done in marketing environments. Of course, it is being done in trade environments also, but it started with marketing environments. Design of experiments. Okay, so you deploy your model with your constraints, and then you take some sample out of the test versus control environment. You can call it as a test versus control environment. which we call DOE. We run multiple test versus control experiments. We call that a design of experiments. Okay, so you take a scenario. I'll come to this slide a little later, the analysis slide. Okay. You take a BAU setup. Okay, so I mean the leads are being passed to the queue, and then from there it is being picked up by the contact center. So you take the queue setup that is there as is in the current status queue, which is BAU setup, which is the FIFO model, and you send some of the leads to the other queue which follows the propensity score model, and then for a given time point you test the conversion rates from both these queues. That's how you add it. A quick nugget of information here. When we were doing the analysis, we found that the earlier the lead is being contacted, the better is the conversion rate. That you can see here from 3-month data points that we have, 9.4%, 9.2, 8.4%. That's a quick nugget of information analysis here. This is the architecture that I was talking about. So we have to have certain architecture in place when we are proposing a new strategy and new approach. Okay. Now, initially, this setup, as we see here, we have an LMS system, loan management system is what we call it. It's a DB. We have the data LMS, and we have the lead entries here. They'll be passed to the queue directly here, and then the contact center team will pick up the leads from the queue, and that's how it happens. There's only one queue initially. I'm not giving the structure for the current status queue because it's very simple, so it can be explained from this diagram itself, and that's the reason I have not included another slide. So we have a DB, we have a table where the leads are created, and then they'll be passed. The queue has that intelligence built to pick up the leads from the table based on the timestamp, and there's only one queue in the current scenario, and that will be passed to the contact center. Now, what is it that we have proposed? We say so it has to be automatic again, right? It has to be run because we have more than 1,200 branches across the country, and we have more than 20,000 employees. 70% of which of them are in the fields, in the branches. So they have to be using this application, using this core real time. It has to be scalable. The approach has to be scalable. The application has to be scalable. The model has to be deployed in a scalable environment. So that's the reason we went with AWS as the cloud environment to deploy our model. So we take the it's an incremental real-time ingestion. So as soon as the leads are created in the table with a scheduling job, they're passed on to an API. It will send the leads for scoring to the model, and then the model scores all the leads back to the API. But we are hindering the scores for certain leads because we need to split the leads from Q1 and Q2 here, right? Like we said, we need to test the DOE. We need to test this. We do test versus control, whether the BA setup is working well or the propensity score method is working well. So we need to have out of 100 leads, we need to send 50 leads to Q2 where it's following a BAU setup, business as usual setup. We need to send other 50 leads to Q1 where the leads are being scored on the logic that we define. So all these leads are, half of them are scored. I mean, technically everybody is scored, but only we send scores leads. Half of the leads scored back to the table, and the rest of the half will not have the score, but they'll be available in the backend at our DB. Now, once these are the responses sent back to the LMS table, this is what happens. LMS pushes all these leads based on the even and odd IDs. Every lead will have an ID ending with obviously, even number or odd number. We've seen from the system that there is equal distribution of leads. So in a given time frame, we have tested the time frames for 1 month, 3 months, 6 months, and 15 days, and for all the time frames, we have seen almost all 50-50 distribution of leads, odd leads and even leads. When I say odd leads, lead IDs ending with odd digit. So that's the reason why we have sent odd leads to Q1 and even leads to Q2. Odd leads will be scored, they'll be scored in the Q1. and there'll be no score in Q2. It will be running as BAU. So now when the dialer picks up, so these leads, even in the contact center allocation also, there has to be a rearrangement. Meaning, now I'm saying Q1 has a better leads with better scores. Now, how do I make sure that all the leads in the Q1 are consumed, and similarly all the leads in Q2 are also consumed? There has to be an equal treatment from Q1 and Q2. Only then we'll be able to tell the business that we have tested this environment in the same constraint. The only difference between these two, Q1 and Q2, is just the scores. One runs on the propensity score, the other runs on the FIFO logic. We have divided or randomly distributed set of contact center agents who are allocated to Q1 and the other set of agents allocated to Q2. So that way we have equal treatment in terms of answering the leads or serving the leads. And what is the output of it? We have done this for almost 3 months now. The output, the conversion rate, this is the dispersal rate. The customer count has increased by 10%. Digital dispersal value has increased by 12%. That's the result. And of course, since we have observed that on an average the max CAT turnaround time for the first call was 3 hours, which we were also shocked. So we eventually made the process, optimized the process at the ground level from the operations and reduced it to 45 minutes. Beyond 45 minutes, the maximum time that the contact center team should take to address the lead. That's it. Any questions? Okay. Over to you, Ma. And before that, so I mean, was this session useful, or was I able to give some information about the industry standards, industry applications, and all right, over to you, Ma.
Participants, if there is any question, you can post your questions in the chat box. I request the participants to post your questions in the chat box. Okay, if there is no question, we'll move on to the top-line session. Okay. I invite Dr. Arun Kumar Sir, Assistant Professor, Department of MCA, to propose the outcomes.
Thank you, ma'am. Am I audible?
Yes, sir.
Good evening to everybody. Good evening to everybody. I am extremely happy to propose the vote of thanks on the 11th day session of this 2 weeks virtual PDP on data science, a revelation of the modern digital era. First of all, I thank our resource person, Mr. Sai Kumar, Divisional Manager, Data Analytics, TVS Credit Services Limited, Hyderabad, for sharing his valuable time. His talk on applications of data science in financial, banking and non-banking sector and his business use cases was really useful to all of us. Thank you very much, sir. Thank you for your valuable time and valuable input, sir. Also, I thank all the participants for their interest and commitment, for showing a great interest over this 2 weeks PDP and attending all these sessions. It is really happy to all of us organizing this PDP. I also thank all the coordinators, organizers, and convener of this 2 weeks PDP for organizing this great event. Thank you all.
Thank you, sir. And I also request the participants to provide your valuable feedback in the feedback link provided in the chat box. I request the participants to provide your valuable feedback in the link provided in the chat box. Thank you, Sai Kumar, sir. Thanks a lot. Thanks for enlightening us. on banking and non-banking sectors. Thank you, sir.
Thank you so much, Soma. Thank you for having me here.
Yeah. We'll keep in touch with you, sir. We are also looking for you to provide some more sessions in the future. Thanks a lot.
Thank you. Thank you so much. Bye-bye.